Hi, this is a demo on Kogito, the new Red Hat sponsored open source framework for business automation, including rules and decisions, processes and cases. The origin of the word is from the phrase by René Descartes, Cogito ergo sum, meaning I think, therefore I am. The C was replaced with a K as a reference to Kubernetes. The target cloud platform of this framework is most applicable, though today, for illustration, I'll just show the three main features of Kogito benefits on my laptop. Under the covers, Kogito uses Quarkus, a Red Hat sponsored open source Java framework for fast and lightweight Java applications. Quarkus switches effort from application startup time to compile time. For example, some applications using XML as configuration need a huge amount of memory for XML processing libraries that are only used once on application startup and then they're not needed. This has a big impact on startup time and memory. So when you move all this processing to compile time, all these XML parsing classes and bloat can be removed from the runtime. And there are numerous other optimizations, similar optimizations that Quarkus does. Quarkus leverages a lot of existing standards and functionality, servlets, CDI, etc. So you don't need to go and learn a new language like Go, for example, to write cloud native applications. Quarkus brings joy to developers through live code updates. No more long waits during application build, compile, etc. With Kogito and Quarkus, you just save your file and it's ready for test. On the bottom of the slide, we can see the three bases of measurement. Traditional cloud Java applications, effectively Spring Boot, Quarkus and optimized JVM mode, and third, compile to native, allowing extremely low memory consumption and startup. Okay, so to the demo. First, live code updates. This is important because it brings joy to your developers. No more MVN install or MVN package or whatever, waiting around for several seconds or sometimes minutes. With Quarkus, when you save the file, in the background it's compiled and it's available immediately, which truly does bring joy to developers and it makes them a lot more productive. So if I switch across to my IDE, you can see we've got a very simple business process here. All we do is send it a RESTful API and it decides based on the payload, based on this drools file here, drools rule, whether that person is an adult or not, and it returns that in the JSON payload. So let's show the live code updates. First of all, what we're going to do is we're going to change this person.java to send back this employed field in the payload. As you can see right now, it's commented out. So what I'm going to do is I'm going to start up my application in dev mode with this Quarkus dev profile, and I'm going to send my API call and I'm going to see what comes back. So that will be ready now, and I have my API call to send up just to post this new person. And you can see that it is an adult, it's over 18, but it does not have the employed field. So now I'll switch back to my code, I'll uncomment the employed, save it, and go back, make the API call again, and now it returns the employed field. So this is absolutely an awesome feature of Quarkus and Kogito, which brings a lot more joy and productivity to developers. So to the second part of the demo. As we mentioned, Quarkus and Kogito provides big improvements over cloud native Java due to its optimizations, removal of dead code, and ahead of time compilation. So what we're going to do is compare this already optimized startup and memory time in JVM mode with startup and memory in native mode. So what we do is we switch back to our IDE, we cancel out of dev mode, and then we're going to start up in JVM mode, just running the jar, this already optimized jar, and we're going to make our record here of the actual startup time, 0.884. I'm going to just slot that into a spreadsheet that I have here, and in order to measure my memory consumption, I'm going to switch to a different terminal, and we run this command here that returns, most importantly, the RSS, the resident set size, or the consumed memory. So you see it's 359K. I'm going to record that here in JVM column, and just to prove that we do have a functioning application, you can see that it was compiled without the employed field before. And now what we're going to do is we're going to effectively do the same thing. We're going to cancel out of JVM mode, and we're going to start up in native mode. We pre-compiled this to native before because it takes a few minutes. You can see that we've got 0.011 as a startup time in native, and similarly if we switch across, we can see that our resident set size is 15K. Just prove that we do still have a functioning application. Yes, we do. So if we look at our summaries here, we can see that the memory usage is 23 times smaller in native mode or over the already optimized JVM mode from Quarkus. And similarly, the startup time is especially spectacular. It's 80 times faster in native mode than in JVM mode. So these truly are game-changing stats and figures, particularly for cloud native and especially for serverless workloads. You can see here there's more information available at these links. Thanks for watching.